Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to our chemistry department program. For our program today is about the Department of Chemistry visiting lecturer, and we're very pleased to welcome Mr. Guarav Abaduri. So, welcome to the program, and I'm Muhammad Irfan Hakim from International Undergraduate Program of Chemistry 2021. So it's a pleasure, and it's a very pleasure for me to be the moderator for this program, which this session will talking about the quercetin moving from laboratory to industry, which will be delivered by Mr. Guarav Bhaduri, PhD, from a lecturer of chemical engineering in Indian Institute of Technology of Jammu. But before that, first of all, may I request to the head department of chemistry, Professor Dr. Adi Darmawan, to give the opening speech. To Mr. Adi Darmawan, time's yours.
Thank you, Irfan. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank to Dr. Guarav Bhaduri. Sorry if my pronunciation is not good. Yeah. It is very beneficial for us to have Dr. Guarav for this webinar. Actually, we already held this webinar in the beginning of COVID 2020. We have more than 20 series because we held it every month. One of the big moment when we invite Dr. Peter Atkin from Oxford University, and at the time the audience is reached to 1,000, more than 1,000. So I think it's very good at the moment. Yeah, we have 20, more than 20 lecture from fifth continent. Yeah, they're from Europe and also from the America and also from Africa. And then after the COVID and everything still goes offline. There is no online and everything is stopped. Then I appreciate for Bu Yayu now try to continue the webinar. Yeah. I hope that 1 hour webinar we can get benefit from Dr. Guarav. And the idea I don't know, because it's like organic chemistry, and my background is in organic chemistry. So I hope that we can get in new insight or the insight from how about the quercetin. Yeah, what quercetin is. What I read this morning is about a natural product that can be produced from the maybe like from we can isolate from the natural product, but I think we can by the title is from laboratory industry, so industry, so it must be product mass production. Yeah, I hope that we can get insight and enlightenment about this topic. Okay, thank you. I hope that everyone is enjoy and can finish, can get information for 1 hour, this information. And also, I thanks to the committee, Bu Yayu and Irfan. Yeah. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Professor Adi Darmawan for giving your opening speech. So, Mr. Guarav, here there is several students from batch 21 to batch 24. So there is a 4 batch who's joining our session today. And as well, there's lectures like Ma'am Yayu, Prof. Adi, and Pak Damar as well, Mr. Damar. And there is several lecturers, they will come also today. Okay, so thank you very much, Mr. Adi Darmawan. And ladies and gentlemen, without further ado, may I introduce to you all our speakers, our guest speakers from India, Mr. Guarav Bhaduri, PhD. But before that, let we see our Mr. Guarav personal CV. I permission to share the screen for Mr. Guarav CV. All right. So here's the Mr. Dr. Guarav personal summary. So Mr. Dr. Guarav is an enthusiastic and self-motivation as a scientist, which educated since 2010 to 2015 in PhD in chemical engineering or nanotechnology in Newcastle University in United Kingdom, and followed by 2005 to 2009 before PhD. Mr. Guarav is bachelor's in engineering chemical in a first-class distinctions in AISSMS College of Engineering, University of Pune, India. Before Mr. Guarav as a researcher, we can see the employment history, which in the nearest, which is now, and since July 2019, he's an assistant professor in Indian Institute of Technology, Jammu, IIT GMU, in 2017 to 2019. Before he's become an assistant professor, he's also an assistant professor in Manipal University, Jaipur, MJ. So this is a different university, I think. And in 2017, only in several months, he's an institute postdoctoral fellow in Indian Institute of Technology, Kharagpur. And in September 2016 to November 2016, he's a research associate of visiting in School of Mechanical and Construction Engineering in Northumbria University in United Kingdom. And we can also see that he's an abundance of working experience. And also, here's an editorial boards. We know that if you want to apply a journal, we need to have acceptance for the editorial boards, of course. We can see he's an editorial boards in Journal of Scientific and Applied Chemistry, as well in the Journal of University of Edinburgh for Pure Science, and POS 1. Mr. Gulfar also have abundance, a lot of projects. We can see here that he's active in a research, consultancy, and as well in a research supervisions. We know that lectures has a project which need supervisors. So we can see that Mr. Guarav supervisions in doctoral students, PG students, and undergraduate students. As well, we can see the key skills of Mr. Guarav in an analytical technique, analytical design software, operating systems, auxiliary training, and languages. Mr. Guarav also have abundance of honors and awards. We can see that Mr. Guarav got a top 50 engineering early career engineers to present their work in House of Commons in London, UK in 2014. We can see abundance of honors and award. We can see in the screen. As well, we can see the reviewer service. Wow, there's a lot of journals that have been reviewed by Mr. Guarav. 21 journals have been reviewed. That's abundance of journal as well. And Mr. Guarav also has a professional memberships in Institution of Chemical Engineers, International Association of Engineers, UK Carbon Capture and Storage Research Center, CO2 CHAM, and Royal Society of Chemistry as an affiliate member since 2013 to 2016. Mr. Guarav also have abundance of events that organized. As well, the other interest that I think is a unique as dancing, historic civilization. Wow. So Mr. Guarav, I think a complete person which active in research in a cultural and in a lot of sector. So we can see the list of publications of Mr. Guarav. He has a patent, reports, and publication, which the publication index is 11 with I-10 index 13, have a 502 citation in Google Scholar. So, and we can see here the PR reviewed conference proceeding. We can see Miss Yayu, Ma'am Yayu names there with Mr. Guarav. And we can see the online presentation and conference presentation. So wow, there's abundance of achievement. There's abundance of your great achievement. So without further ado, maybe to Mr. Guarav Bhaduri, time's yours to deliver your materials. Thank you.
Right, thank you, Irfan. I think so. You need to unshare your screen. And also a PhD in chemical engineering. So this is one of the labs that we have on campus. Now, before I move ahead, let me first say acknowledgement and thank you to a few people. So this is my colleague, Professor Chadda. She is a retired professor of biochemistry from the Indian Institute of Technology, Madras. Piyush, who is in the Department of Chemistry, IIT Jammu. This is my doctoral student, Arif. So majority of the work that I'll do is based on his PhD thesis work. So he has a bachelor's in biomedical engineering and a master's in nanotechnology. And these are some other students, those who work with Arif on the similar project. So we have Jamit, who did her master's in chemistry thesis with my lab. I have Atta and Divya, who are project staff on this Quercetin project. And then I have Ravi, who's doing his master's work with me currently. So let me begin the talk by introducing a term called nutraceuticals. So nutraceuticals are chemical compounds that are classified as a nutrition and a pharmaceutical substitute. Okay. So if you go into the market and you find this, omega-3 fatty acid tablets, or you'll find, oil with fortified nutrients, you'll have food, you'll have bread, which gives you a lot of different things. You have cosmetics with vitamin C and all these different kinds of products. So all these compounds that are being added to fortify dietary and cosmetic needs are called as nutraceuticals. Now, depending on where you are, there are different definitions of this term nutraceutical. And it is more of a dietary supplement rather than a pharmaceutical that is available. So with Professor Chadda, I have one online lecture series on nutraceuticals. Now, here what we are interested in is this term product, which is quercetin, which is a nutraceutical, and there are a lot of different nutraceuticals available. So generally, these compounds are provided as a nutrition supplement. So in India, we have a few companies like Himalaya and Dabur, which actually produce tablets of herbal products. And many a times you have these different companies which are there, some run by Unilever, some by P&G, which provide you food supplements like cornflakes with some extra iron or extra calcium and extra magnesium. So all these different kinds of things are actually nutrition supplements which are added to food. And what we work with is one such nutraceutical molecule, that is quercetin. Now, nutraceuticals actually come from different kinds of sources, and they are secondary metabolites that are produced by plants. So here are some nutraceuticals that you can see here, which are available in garlic. So these are Nigella seeds. In India, we call them kalonji. They are like small black color seeds. And there are a lot of different nutraceuticals. These are different nutraceutical molecules which are available in these small seeds. Okay. So continuing with that, those were small molecules. These are bigger organic molecules which are there. And each one of them provide a different kind of nutrition supplement to people, to fortify our body's defense mechanism. Okay. And they're actually required for our own well-being. So this is green tea, and one of the major nutrient that you're looking from green tea is catechin. Now, depending on the tea that you have, so it can be black tea or green tea. Depending on what you have, you'll either have catechins as very high, which is green tea, and as you move from green tea to black tea, the content of catechins will go down and you'll have a high content of caffeine that will start coming up. So these balance one another and depends on how the tea is processed. So extraction and utilization, people say that green tea is very good for health. It helps reduce weight and so on. So the major molecule that you're dealing with is catechin, and these are some sugar-based catechins that are available in nature. Okay. Now, coming to the molecule that we are interested in, it is called quercetin. Now, quercetin is an antioxidant flavonoid. I'll tell you what a flavonoid is. If you look at this figure here, this is the chemical structure of quercetin, and there are different sources in which quercetin is available. Now, elderberries has the highest amount of quercetin available, followed by red onions, white onions, cranberries, peppers, chilies, kale, blueberries, apples, and so on. Now, one thing that you'll have to notice is when we talk about onions, and my group generally focuses on onions, quercetin is not present in the bulk body of the onion. So when you have an onion is used extensively in cooking, quercetin is present in the peel of the onion, which we actually discard. And it is an important antioxidant. So there are different kinds of physiological applications that people have studied for quercetin. So it is anti-diabetic, it is anti-cancer, antiviral, anti-inflammatory, antibacterial. It helps avoid obesity. It is an antioxidant and an antifungal. So if you see, quercetin tends to have a lot of different applications. Please note that this is not a drug. So which means it does not aid in treatment of these different kinds of physiological issues, but it helps prevent these physiological issues. And this is something which one has to understand about nutraceuticals, is that nutraceuticals are supplements that would help prevent different kinds of physiological problems that you have. And what we'll be looking at is the different kinds of applications, and what we're looking at this quercetin and its different types present in onion peels, and what we do in our lab to work with it. Okay, so quercetin is a part of naturally occurring compounds called flavonoids. So these are different kinds of structures that are there for flavonoids. This is the basic structure, which is a flavonol. And as you keep changing this molecule, you will have flavanols, isoflavone, flavane, lavanol, and so on. So as you keep modifying this basic structure of a flavanone, you'll have different kinds of flavonoids that are produced. Additionally, within the onion molecule, within the onion shell, within the onion peels, the outer skin of this onion tends to have quercetin, but it is not just present as quercetin. It is present as a multitude of glucose integrated structures. So you have quercetin 3-glucoside, you have quercetin 3,4-glucoside, you have quercetin rutinoside, or what we call as rutin. You have other structures of quercetin that are available. So quercetin in nature is mostly seen as a glucoside, mainly because quercetin by itself is sparingly soluble in water. It has very low solubility in water. However, its glucoside compounds, which are these, generally tend to have good solubility. So therefore, the bioaccumulation of these glucosides are much more easier for the plants. Now, we as humans would like to convert all of these into quercetin by hydrolysis mechanism, and based on which the yield of quercetin can be increased in as a natural product. So why do we choose onions? Now, this is just data that we have got from the United Nations Statistical Organization of Food, wherein you can see that over the last few years, so the data that is available is still 2021. They have not updated the 22 data. So we are talking about the most recent data available in the United Nations Statistical Organization. India is one of the largest producer of onions. And if I just scroll back, if you look here, red and white onions tend to have very high amount of quercetin as compared to some of the others. And elderberries are not that very common in the parts of the world, but onions are. Okay. So therefore, onion is extensively used in Indian cuisine, in Chinese cuisine, in South Asian cuisine, as well as in European cuisine. So therefore, it is extensively produced agricultural product. So over the years, the trend has changed. Initially, China was the largest producer of onions. And in 2020, India overtook China for becoming the largest producer of onions. And the world production of onions is around about 106.95. All this data is in million metric tons. Okay, so that is million metric tons. So over 106 million metric, to say 106.5 million metric tons of onions are produced worldwide. Okay, this is just, and we see that the production is actually increasing over the years. Now, if we have a higher production, that means we have higher waste. And across the globe, we have a lot of onions that go to waste. Now, when we talk about wastage, we're talking about not only things getting spoiled while moving from field to the market. Also, there are different kinds of wastage that is produced by these onions. So when we are looking even at this number of waste, again, this is in million metric tons. So we have quite a lot of waste being produced from onions. Other than that, whenever you get onions to cook at home, you'll be removing some of the peels and throwing them off. That also generates waste. And that is what my group is actually interested in. So when we are looking at extraction of quercetin, there are different kinds of methods that are available. So my group generally works in these two, wherein we have done more work with oxalate extraction and purification of quercetin, and the other thing that we are working on is subcritical water extraction. So question is how difficult it is to extract things. Mainly when we talk about nutraceuticals in general, it is as simple as making a cup of tea. So all of you must have used a tea bag and in a hot pool of water, and you'll see that some brown color solution or some yellow color content just keeps mixing within the water. So if you're doing green tea, you'll have a yellow color solution, and if you're making black tea, you'll have a dark brown to black color solution that is being made. So what is happening is these solvent molecules tend to come in contact with the solid, and some amount or some characteristic molecules from the solid enter into the solution. And that helps in actually utilizing these different kinds of molecules. So what we are generally interested in as engineers is the rate at which these molecules are being separated. Now, as I'm talking to most of you all from a chemistry background, so as a chemist, the things that are of interest to a chemist is what would be the right choice of solvent used to extract these chemicals. Depending on the functionalization of that is available for all these different kinds of molecules. So, I showed you a lot of different kinds of molecules that were there, right from catechin to epicatechins and pyranine and all these. So different molecules have different solubilities in different solvents. Design and choice of solvent to give best yield is where the chemists are extensively working, mainly within natural products. So what we deal with in this is the chemistry of natural products. Now, functionalization and unfunctionalization of these different kinds of active components is something which actually interests chemists. I am not dealing a lot with chemistry of it because not my forte area, but recently we have been, so we have Professor Chadda, who's a biochemist, who's actually supports the group with all the chemistry related stuff that is there. We generally deal with the engineering aspects of this kind of nutraceutical production. Okay, so as an engineer, can't help it, I have to show some formulas. So this is called as fixed law of diffusion. So when you see this swirl of this brown color pigment that comes out, this actual movement that happens is because of fixed law of diffusion, which means, if I'm not mistaken, all of you must have studied physical chemistry, wherein you're talking about different kinds of reaction kinetics and the reactions work. So this is a physical process wherein some compound is there, which is partially soluble in the solid and partially soluble in the liquid, and they come and so when you have a pure liquid come in contact with the solid, some amount of it dissolves. Now, what you see here in these 100 ml beakers is one tea bag, and that initial tea bag was put in water. And over a period of time, we have, for each of these samples, we had boiling water that was put, and the tea bag was dipped multiple times till the color change did not stop. Like there was no change in color. And as you see, we had this as run one, this is run, this is the first time we dip it, then the second time we dip it, then the third time, then the fourth time we dip it, then the fifth time we dip it. At all stages, the temperature of the water was kept constant, and you'll find that the color of the solution is turning from dark brownish color to a very faint yellowish color, which implies that the amount of material moving out of this tea bag changes with the kind of compositional change. And this is something that we are interested in, mainly when we are trying to extract quercetin. I'm giving a very rudimentary example to explain the kind of work. Now, let's look about a little bit on the thermodynamic aspect. Won't go into details of it. So the thermodynamics of extraction is governed by chemical potential, which is the total Gibbs energy that is available over a given for a particular compound over the component fraction. So generally what we are looking at is a chemical equilibrium, that is the chemical potential of the solid is equal to the chemical potential of the liquid. And in this case, these are two parallel runs for the same. And in this case, every time that we dip that tea bag, that same tea bag in a fresh pool of water, we have this equation coming into play. So the chemical potential of, say, over here, as we are looking at green tea, so the chemical potential of the catechins that are available in green tea in the solid, and the chemical potential of the catechins available of green tea in the liquid, they come to an equilibrium and extraction will stop. You change the equilibrium condition and extraction again starts, and slowly you find that the amount goes down, because every time we have re-dipped it in water, the solid content already was low, and as we keep adding more and more fresh solvent, we tend to have lower and lower concentrations. So for an engineer, the major challenge is, once you have all these low concentrations ones are the ones we actually have to tackle, so that we can get very good yield at the end of it. So coming into quercetin, what is the process that we are dealing with? So we deal with biomass harvest. We pre-treat the biomass. So this is the onion peels that we actually get from the market. So when you have a wholesale market, or when you have a supermarket, a lot of onion peel waste is then dumped outside. So we are interested in that. We go collect that. We do a little bit of pre-treatment, that is, we nicely clean it with water, dry it, to remove any dust particles that are there. And after which we try different kinds of processing. So currently we are dealing with sock slit, but we will soon start working with ultrasound assisted extraction and assisted extraction to increase our extraction kinetics. And we are currently dealing with supercritical fluid extraction. Then this is where we have worked extensively, is the isolation and purification of quercetin. So say when I have the solid biomass, we tend to remove most of its composition. The solvent we work with is water. And then we try to purify the quercetin which is there. So over here, we have a lot of different compounds coming out. And then we purify to get the exact chemical that we are dealing with, dry it out, and package the final product. So what are the different methods for isolation of quercetin? The most commonly used method is column chromatography. As a chemist, whenever you are producing different kinds of organics, mainly in organic chemistry, we tend to use column chromatography quite very often to isolate and separate. Also, we use thin layer chromatography to identify and find out, identify and quantify. There is quantified chromatography, and that is thin layer chromatography, where you can actually quantify the amount of material that is being produced. Okay. What we in our lab work with is a process called as liquid extraction. So the kind of method that we have developed is we have developed a liquid extraction method that is far superior to what is available in literature. And we compare it with column chromatography. So to say, this is the process that we have. So we have our organic solvent mixture, we have quercetin, we mix them together, and then because these are immiscible, the phase separation takes place, and what we get is we get purified quercetin in the organic phase, and we get the water phase out. Now this is a very simplified image that we are showing here. We do not just have quercetin as one molecule. So this is what we did in our equilibrium studies. So this we don't only have quercetin as a single molecule. We have a mixture of different compounds, of which we purify quercetin, and then we test it with the purity with different methods. So these are some of our results. So you see that column chromatography can give us a yield of around about 2.2 milligram of quercetin per gram of dry onion powder, using that we could isolate using column chromatography. Whereas the liquid extraction method, which we have developed, we can increase the yield up to 6.4 mg per gram. Please note that when we talk about these nutraceutical molecules, they are very minute in quantity within the entire solid biomass material. So therefore we get very low yields that is there. Now the purity of the quercetin that we have got, we have actually worked out using HPLC to see whether the quercetin that we have got out of this extraction process is good or bad. Now, what are we currently working with? So currently what we are working with is this purification. We have done extraction process. We are now in the verge of converting it into a continuous process that can be easily scaled up into a process wherein, you know, you can the best ideal situation that we are trying to develop, and we do talk to a few industries. We have two chemical companies that we are in contact with, one of them being Tata Chemicals to be exact, wherein we are trying to develop this kind of a technology and market it to field, wherein one can actually set up a plant, because for us as a largest producer of onions, and we have a lot of kitchen waste for these onions. Even if we don't look at kitchen waste, we have a lot of what do you call it, market waste that comes, you know, the wholesaler markets tend to the dry peels just peel off and they're just shoved in, and they're mostly used as animal fodder. We would like to extract this quercetin out of it and then purify it, sell it as a marketable product that people use in food materials, people use it in cosmetics. There is a lot of application for quercetin in cosmetics that has recently come up, and it helps in anti-aging. So therefore, anti-aging creams tend to have quercetin now being added into it, and so on, right? So in conclusion, we generally, I spoke about nutraceuticals. So what are nutraceuticals? Then quercetin as a nutraceutical and its different sources, the different ways in which quercetin can be extracted. I've given you a very simplified version of how quercetin actually is removed. It is not that simple as I said. Then the isolation and purification of quercetin, which we have our own process that we have developed in the lab. And our future work that we are looking at is moving from this lab scale into generally going into further design and continuous design generally with scale up. So we currently have a 5-liter reactor capacity extraction of quercetin. Now we are developing continuous liquid extraction method, wherein we can actually at a pilot scale demonstrate that we can purify quercetin from the onion waste that is available locally. And provided we are having a few industrial partners who would be interested, if we can demonstrate a pilot, they'll be taking it further on to go and convert it to a full-scale process, right? With that, I think so I have time for some questions if anybody has any. Thank you so much.
Okay, thank you very much, Dr. Gaurav, for your kindness and for your presentation. That's a very interesting materials, and I'm really sure that it's very beneficial for us, which quercetin, we know that even organic chemistry and physical chemistry use the quercetin as well. And as Dr. Gaurav mentioned before, that there is a sharing a question and answer session. So now, if anyone has the questions and want to ask them Dr. Gaurav, I'm very sure that Dr. Gaurav will be pleased to answer them. So, ladies and gentlemen, and all of the participants, any questions or any more questions to raise? You may raise your hand using the raising hand features. Please, to all of the participants. Okay, as what Ma'am Yayu said, maybe you can also write your questions in the chat box in the meeting chat. You may please to ask.
Maybe I will directly ask to Dr. Guarav, yeah, because I can open my mic. Okay, so Dr. Guarav, I think this is a very good presentation and also insight. So thank you so much for the sharing. And okay, this is about the quercetin from laboratory to industry. I think this mostly is about the extraction of the quercetin in the laboratory. And then you said that for the design for scale up, this is still in progress, right? Yes, the data that you show us is quite interesting, especially about the amount of the onion in India is quite the highest, I think, yeah. Because you know, Dr. Guarav, in Indonesia, do you know about the Bombay onion? Bombay onion. In Indonesia, it's called bawang bombay. So this is onion, the big onions, and this is quite expensive, I guess. Here. Yeah. Okay. And for example, if we use a Bombay onion or onion, yeah, and then this is expensive, even though when we use only the waste, what do you think about how to say, like sometimes it's kind of, it's not useless. I mean, like because this is expensive. Do you get my point? Because this is expensive, so it could be not many people use onion, even though in India probably is quite large for the amount of the onion. What do you think about this?
Well, it depends on the different countries that so we not only produce the highest amount of onions, we also export the highest amount of onions. And one thing that happens is, irrespective of wherever you are, whenever you're dealing with onions, you're going to take that dry scale on and throw off. And like there's just part wherein we are talking about quercetin, we also try to work and see if we can actually convert whatever is left out of that onion into some other chemicals or convert it to fuel, generally convert it to fuel. But depending on the country that you're in, the usage of onions changes. So we actually, this was a local problem that we are dealing with because after COVID, there is a drastic shift of manufacturing that is moving away from China into Southeast Asia and South Asia. So countries like India, Bangladesh, Vietnam, Cambodia, Thailand, Malaysia, Indonesia. So all these countries are now trying to unindustrialize the production in China. And most business companies are moving mainly to Southeast Asia. So in that case, for these countries and for India, in order to get that kind of production out, these technologies are there. And what I have just spoken about onions as a quercetin source, but depending on which part of the world you are, you have different materials through which you can get this. So just looking at quercetin alone, if you're looking at any other nutraceutical, you'll get it from a different source. So my major idea is to work with waste.
Okay, thank you, Dr. Guruv. And one more question. Based on your experiment, you used like a CC. This is a column chromatography, right?
Yes,
Yeah,
column
column chromatography and also LLC, liquid chromatography.
extraction.
Said, yeah.
It's liquid extraction.
Oh, liquid extraction. And then, yeah, based on my experience as well, if we use column chromatography, one of the, how to say, like unbeneficial, I mean, the, how to say, disadvantage, yeah. This is quite complicated because we need like a column and also, for the status phase and also mobile phase. Yeah, status phase we use probably like a silica, I guess
Yes.
silica gel.
Yes.
So it's quite expensive, not expensive, I mean complicated. And I guess also need complicated, not complicated, I mean, because we use column and also like a silica gel and so on. But when we use liquid extraction, I think this is quite simple and also cheaper, I guess. And then we got a lot of how to say, a lot of extract, right? But how about the purity or impurity? Did you also observe about that? Thank you.
Yes, so we compared the purity of the material that we have got with the column chromatography material that we have. So what we did was we took the same extract and we tried to isolate and purify quercetin. So commonly we use column chromatography, and you rightfully said expensive. It uses a lot of I won't say very highly expensive as such
Yeah.
when we talk about large scale production, but it uses a lot of solvent.
Yeah.
So for us, for just getting quercetin out, we need around about 2 liters of solvent. And in the other case, the liquid extraction, we have optimized it to reduce the solvent amount to say 10 ml. So for 100 ml sample that we have of quercetin that is extracted, so not just quercetin, the entire extract that we get from onions. In order to purify quercetin from that, we need around about 2 liters of solution for 100 ml using column chromatography, as well as silica. That is a part of it, but obviously you can wash the silica and reuse it. But when we talk about liquid extraction, we have reduced it down to 10 ml. So we just need 10 ml of extract and we can get purified quercetin. A. B, the purity which we have done, laboratory based analysis which we have done, we have got around about 83% pure quercetin by column chromatography, and the liquid extraction gives us around about 93% pure quercetin. So the purity has also gone up.
Oh yeah, okay. So meaning that liquid chromatography is quite, how to say, like I hope Mr. Bambang is still there, is still here. Oh, okay. Oh, he is not here. Yeah, Mr. Bambang is my colleague who is working on natural product isolation. Yeah, okay. So yeah, so it's meaning that the liquid chromatography is quite, I mean, better than other extraction
Yes.
method. Yes, because it's cheap and also the purity is quite 90%.
So we have
Yeah.
around 83% purity that we are getting.
Mm-hmm.
We can tune in a little bit parameters and we can increase the purity.
Because
So
normally when we use liquid chromatography, in my opinion, yeah, the purity I think is not quite high.
it depends.
Yeah,
It depends. Like,
probably solvent. Yeah, I mean like the combination of the solvent, because sometimes we, how to say, like a mix between polar and non-polar solvent, I guess. Yeah, so it's depend on the the
that's where the
mobile
chemistry
phase.
comes in.
Yeah.
That's where the chemistry comes in.
Yeah. You know, even though I'm working on nanomaterial, on material in organic material, I when I was undergrad, I work on the natural product isolation. So that's why I know.
Yeah, that's the main key is to like the chemistry part of it is to design the solvent.
Yeah,
And
correct.
like quercetin is one natural product that we are looking at. Another natural product that my group is looking at is called azadirachtin. Now, azadirachtin is produced by neem, and it's a biological. It's actually a very potent insecticide, but purifying it from the extract is a headache. The most simplest way of doing it is a 8-step liquid extraction method,
Yeah.
which is available in literature. And because it is like, you need ethanol and you need hexane and you need propanol in a series of
Yeah.
contacts with the extract in order to purify it,
Yeah.
it is very expensive.
Yes, exactly. Yeah, in order to get especially when we want to get 100% pure of the quercetin. Yeah, so many steps that we have to do as well.
Yes.
Okay.
So
Yeah, I think this
there's
is
one
another
question.
question. Yeah.
Yeah.
In the chats, quercetin
Okay.
is maybe Irfan, please, because you are the moderator.
Okay, sure. Okay, let me
I'm
read the
very
questions.
enthusiastic. Okay.
Okay, okay, so let me read the questions from Mr. Damar. So Mr. Damar said, thank you very much for your presentation. I have questions. So here's the question from Mr. Damar. Quercetin is well known as an excellent antioxidant due to its many phenolic hydroxyl compounds, or hydroxyl groups, sorry, phenolic hydroxyl groups. However, for other bioactivities such as antibacterial effects, are these also determined by the number of phenolic hydroxyl groups? Or are there other functional groups that influence quercetin's bioactivity? Thank you, Dr. Gaurav. Maybe please, Dr. Gaurav.
Right. Regarding bioactivity, there are two different things that are there. So you're correct. The different kinds of OH groups that are available on the quercetin molecule actually help in its bioactivity. Though there are not a lot of studies which actually look at the mechanistic chemistry on how the things are taking place. So most people, what they do is they'll just extract it, go do some activity tests and just finish it off. But the mechanistic understanding, because also there is a double bonded oxygen which is there. So I'll just if I can scroll up to the structure of quercetin. Right. So what you see is this OH group and this oxygen are the major key players in formation of compounds for activity of quercetin. So you have the 3OH, the 7OH, and I guess the 4-OH, which is there. So this 4-OH, this 3OH, this 7OH, these 3 OH groups are generally what give a lot of reactions with quercetin, mainly in the biological context. In the chemical context, you can work with some of the others. Another thing that people have reported is this double bond O. However, because this double bond O is placed in such a way that it directly does not take part in the reaction, so this OH and this O are together used for showing some of its biological activity. But there is not a lot of information available. So when we did a few kind of clinical studies that we were looking at, and there are very few clinical studies which are available for nutraceutical applications because they are not classified as pharmaceuticals. So not a lot of clinical studies are there. And for most those who work, they use an extract rather than the actual isolated compound. So generally what they will do is they'll take the onion extract and create a formulation and try to do the clinical study with it rather than the pure compound. So they would say that this is high in concentration, so therefore it is working. But there are very limited clinical studies which are available in this. So hopefully, I think so I try to answer your question.
Okay, so Mr. Damar, maybe? Is there any following questions or any response, please?
Okay, thank you for the time, Ivan. Also, thank you for your answer, Dr. Guarav. Actually, when I was in master, I doing antioxidant activity, also using quercetin as a standard. Yeah, so I write that question because my supervisor tells that mostly quercetin using as a standard for antioxidant because
Yes.
it has so many hydroxyl groups, phenolic hydroxyl groups. So if quercetin become a radical, it's become a stable radical. But I didn't find the answer from my supervisor. We know that quercetin have so many antibiotic activities, but there is no exact answer. The mechanism actually that same that as you said before. So yeah, maybe thank you for your answer, because maybe sometimes I also catch from your answer that the bioactivities it causes not itself from the functional group, but also the conjunction with the structure, and also maybe like a resonance the structure after quercetin react with the target molecule. But it must be used a clinical and also like a real time monitoring about the reaction. Okay, thank you so much, Prof. Guarav. So
Thank you.
interesting presentation. Okay, thank you, Irfan. I give your time back.
Okay, thank you very much, Mr. Damar and Mr. Guarav. Are there any questions? Okay, since there's no questions, so maybe I'd like to ask to Mr. Guarav as well. So, Mr. Guarav, I'd like to ask about the quercetin itself. As we know that what I've read before, also before your presentation, that quercetin is very risky or susceptible to degradation, right? Especially when it's exposed to light or not in a good condition, such as the pH, temperature, and other as well, heat and oxygen. And my question is how to overcome challenges of the chemical stability of quercetin during the storage and processing in a significant challenge in supplement research and productions. We know that when we make it into pharmaceutical industry, that there is some maintaining or there's some processing which could affect the temperature, could affect the pH, could affect the sustainability or this stability of the quercetin. So my question is how to maintain the stability until it become as a product. Thank you very much, Dr. Guarav.
Right. Thank you, Irfan. So one thing that happens is most people do not use quercetin. Like if you're using it in the, say, in the food industry, we generally don't put quercetin as it is. So you would actually put it as a glucoside because the glucoside has a high absorbance rate in the body as compared to pure quercetin. Also, the glucosides are present. It goes through a hydrolysis reaction and you take out the sugar molecule and you'll get quercetin. But as Dr. Damar said, like you would have quercetin is generally used as a standard for a lot of different things. So whenever you're doing natural products, you would find quercetin and gallic acid. These are two benchmark standards. Everything else is measured based on them. So in that case, one is remove moisture as much as possible. So one thing that most chemicals go through degradation is because of moisture. So removing moisture and trying to see there is very little humidity there is one very important step in storage and utilization. Second is it is photodegradable, so therefore we generally tend, and with industrial chemicals we don't have this much of a problem as compared to lab chemicals, that industrial chemicals come in seal tight containers, so they are metal containers, no problem of light. But when you're talking about your lab, where it'll come in a glass bottle, you'll open it, it'll not be closed, there'll be cross contamination. So those things happen mostly when we are dealing with laboratories. When we talk about the industrial scale movement of chemicals, we generally tend to seal tight them and send it through transport. But it happens that sometimes due to mishandling, things can take place. Another thing is for majority, as coming from an engineering perspective, in majority cases, wherever temperature is something that affects, we try to see that the temperature doesn't rise. So we try to put mechanisms in place, we try to put equipment in place so that the temperature doesn't rise. And based on which we can process it to the best of our ability. Obviously, there'll be some amount of degradation that would take place because of internal heating that we can't help because a problem with the machines itself. So, whenever if you have ever gone to a flour mill or if you have ever just, pound some things at home, you'll see that if you keep pounding it for a long time, it'll start heating up. That's because of the, impact that is generating some heat. So these are some intricate parts of machinery which is there. So we generally try to see that this does not affect. And in majority cases, we deal with inert atmosphere. So we'll either purge nitrogen through the system so that oxidation does not take place. So if we are making formulations also, mainly in the pharmaceutical industry and in the cosmetic industry, we use this, as well as in the paint industry, we use this, is we do not let any of these compounds come in contact with air. So the entire thing is done in nitrogen. So you'll have a nitrogen isolation plant and that would supply nitrogen and everything would be dealt with a nitrogen. So that because like I'll give you a simple example, the paint that you get, as soon as it comes in contact with air, it will convert into a thick polymer. And you just prick a hole in that polymer, inside the paint is liquid, where the upper layer will polymerize because it actually does the polymerization reaction by coming in contact with air. And once that layer is formed, it is impenetrable for the air to go in. So therefore the inside is still liquid. The same way we would do over here is we would try to seal it off with nitrogen and then do the processing to avoid oxidation with it.
Okay, thank you very much, Dr. Guarav. And before I highlight your answer, and I think this is new knowledge for me, that you mentioned that after consumption, only a small portion of quercetin, pure quercetin, that absorbed into the bloodstream, so we don't use quercetin. That's a new knowledge for me. Thank you very much, Dr. Guarav. And for all of the participant, maybe is there any questions? Oh, okay. Maybe we say time is up, so maybe we close the questions and answer stations. So once again, thank you very much, Dr. Guarav, for your kindness to share all of your knowledge and answer all of the questions that have been delivered to you by all of the participants as well, me as well. And ladies and gentlemen, and all of the participants, so this question and answer sessions maybe will be the last sessions for our program today. And once again, thank you very much for Dr. Guarav for your time and your willingness to share your knowledge with us. We are very pleased to receive all of your knowledge for us. And lastly, I thank you to all of the participants in this visiting lecture, as well as the head department, Professor Dr. Adi Normawan, Ma'am Yayu, as the PIC, and all of the lecturers and participants today. I hope you enjoyed the program, and I look forward to your participation in future agenda. I'm Muhammad Rifan Hakim. Let me close this program. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Have a nice day, Dr. Guarav, and all of the participants here.
Thank you so much. Have a nice day too.
Thank you, Dr. Guarav.
Okay.